session. Greeting of the day. In today's class we are going to talk about the various sheet metal operations, and we have covered some of them in the previous class, such as spinning, bending, shearing, blanking, piercing operations, and remaining part we will continue. One more I am coming here about sheet metal bending operations. Now we moved from blanking and piercing of shearing treatment to the bending treatments we came. Shearing is over. Another second part is bending. Metal, now onwards we are not going to cut the specimens. Shearing is belong to cutting treatments. Now the specimen will be as it is. We are going to convert the shape. Volume will not differ. There we have terminated, we have cutted the specimens. That is belong to shearing treatments. Shearing treatment divided into blanking and piercing. Now I am coming to bending. Metal on inside the neutral plane is compressed, while the metal on the outside plane, outside the neutral plane, is stretched out. You see, this specimen, let us consider this is flat now. Let us consider this is flat. So this is in the flat condition, and it contains one axis of central axis, neutral axis, right? Now, metal on inside. So this I am bending in this U shape. Now I am going to bend here like this. The metal inside the neutral plane is compressed. You see this point is going to compress here. This point is compressed. But the material which is outside, it means this side it is compressing and this side it is stretching. In such a way, the outside part is going to stretch out. Outside part is going to stretch out. This part is going to stretch out above the neutral axis, which is the outer side. So likewise we are forming the bending action. What I am conveying here, the neutral axis inside part is bending. It means compressing, and outside part is stretching out. This compression and the stretching combinedly is going to form a bending action. Without this it is not possible. This property is to be in the material. So that is what this image is. Now I am coming to the classifications of bending. On that we have taken number 1 as V-bending process, such as V-bending treatment. So here V-bending is very simple. What we should have, we have a fixed die. We have a fixed die here, and then we have a fixed die here. You see, it is a one die is fixed over, and then one more die which is contain the shape of the operation, which contains the shape of the operation. This is going to be a V. So I have the punch. I have the punch. This is die which is kept, and this contains the cavity, in which the material is going to be punched inside, and this is going to generate a V shape. The specimen is going to convert it into V shape. So that is called as V bending operations. Any shape it can be, maybe U bending also. So punch to be in the U shape. So here the punch is in the V shape and naming is a V bending operations. So for low productions performed on a brake press, V die, see V die. So this is a V die, fixed die and V die are simple and inexpensive. So after this is the first condition, number 1 condition, and this is the number 2 condition. After bending, it looks like this. You see, this is in the flat. Now after giving the force, here, it is converted into the V part. Over. Now the second one I am coming about edge bending operations. The same plate I am taken here. Same specimen has been taken like this. I want to bend this specimen in this format. This specimen in this format I am bending. So what happens? I want to bend here, not the V. I am not giving the force here. I want to give the force at the corner. I have to give the force at the corner, but also I have to hold this too. I want to hold this too. Then only it will can able to come over there downwards. So that's why I am putting one die here, and I am putting one die here also, and I am giving the force at this point, I am giving the force at this point, I am giving the force at this point, and therefore it is going to bend like this. So very simple method. So see here, I have kept the two specimens numbers, die 1, die 2, and this is for holding the specimen. For giving the force, I have used the punch here. It is going to press. After pressing, you see how it is changed. It is changed in this format. It is changed in this format. Initially, it is straight. This part is going to bend. This part is going to bend like this. So it is an edge bending. So this corner edge I am bending. Therefore, I am naming this as an edge bending process. Pressure pad requires and dies are more complicated and costly also, because we are 2 to 3 we are using, so it is costlier. Die increases, cost increases. Now I am coming to the next operations in the same bending treatment itself. Spring back V bending operations. It's a V. We are going to use the same formula here. Same die, fixed, and one more punch we are using. But here you see, increase the included angle of the bend part related to the included angle of the forming tool after tool is removed. What happens? I need a bending operations like this, which is named as a R. But I am creating a die like this, and I am giving a force here, which is this force initially to be restricted, will be restricted by the specimen. So what happens? Even after removing of the specimen, it is going to lightly, this resistance creates lightly to elaborate the specimen. Therefore, automatically comes to from the RB position, the radius as can be expanded to original position of R. When the bending pressure is removed due to elastic energy, see, due to elastic energy remains in the bended part. Elastic energy is here. Elastic energy is here, causing to recover partially. We have given huge force and have bended, but after removing, this elastic property of the specimen caused the specimen to slightly, partially increasing the angle. So let us consider here, if it is bending angle, if the bending angle here is 90 degree, after removing, due to spring back effort, due to this elastic energy effort, this process will convert it into maybe 94 degrees angle. So these 4 degrees are caused by this specimen's elastic property. So this we should know, and we should plan how far this bending angle to be kept in such a way the spring back effort will be takes place after removal, and we will get the desired product. So we need the desired product is 94. We should not keep here for 90. We should again do an operation in such a way it can elaborate later and then come to 94. So such likewise we should again it should decrease, and then after removal it should elaborate. So we should plan those things. It should be taken care. So spring back effort, see how it is formed there. So 2 dies I have kept, one die and one, this is named as a pad which is kept at the top. And then where punching action has been done during and the final. We have not removed. This is 90. This is 90. There is no gap. Now we have removed. What happens instead of 90? You see here the small angle has been increased here. This gap. This is 2 degrees or 3 degrees has been increased. This degree. You see, I think visible. This here it is 0. There is no gap. After removal, due to spring back, it is slightly increasing. We should plan that. And then, if it is okay, we can accept. That is named as a spring back effort. So, wiping die. Now, on the bending, one part of edge bending, V bending, we have done. Spring back effort. Another form is there. We are naming this as a drawing operations. We are naming this as a somehow drawing operations. How I am doing this drawing operations? It's not a shearing. We are not going to cut. We are going to convert a product. I have taken as usual the dies. A die has been kept, and then I have kept the sample in between. Yes. After this, I want to use the supporting of pads, or else the die too we can keep. So here also I have a supporting dies or pads. We are keeping and supporting these things. And here I have supported. Therefore, it won't come. Slowly it will remove. Now, I am not having a die in form of a sharp. Sharp I am not having. See, I am not having sharp. This is lightly bended. So we are going to do the drawing operations. So these corners are not sharp. It is a smoothened surface. With respect to this, I am applying the pressure here. I am applying the pressure. What happens? This specimen is going to come down, and slowly it's going to elongate and is going to form this. So how it will form? From this action you see here, from this action you see there. So it forms the cup here. It forms the cup here. I am permitting this FH force given here is different. The force given here is different. It slowly the material has been taken and converted into the cup format. Initially, how much it is we have kept there? We have kept the total diameter of dB. And this dB total has been converted, this total length has been converted into small dp. After drawing operation, it is going to be like this. It is dB is before drawing before. But after the penetration, drawing after penetration has been given, after the punching has been given, punching has been given, it converted like this. And maybe you can understand this is a cup. Like a cup it has been converted. So likewise. Now one more point is that a stretch forming efforts. I am naming this as we have kept as usual the products. The product has been kept here, and now I am going to stretch. I have holded tightly this two. After holding, I am not using the die here. Die is used to hold and receive the squeezing or punching. But here I have just holded the two ends, and both are free. And I am just pressing there in such a way. The elastic property of the material makes it to elongate. It makes it to stretch. So that stretching operation I am doing through a die which contains the V design. So I am stretching here. What happens? It is going to lightly stretching and force acts here. You see, the force are in this way. Two sides are holded. Here it is holded, here it is holded. And I am pressing, force is given here. So it is going to stretch out up to its limit of extension, up to its ductile property. But we are working itself at the ductile property only. So we are stretching and we are doing the stretching operations. One more is there in the same another sheet metal forming, that is a spinning effort. You see, a very simple method. I have kept a specimen here, and with this specimen I have having a shaft connection, and it is going to rotate. This shaft is going to rotate. So this shaft is rotating. While during it is rotating, we are keeping a tool. This tool has been kept here to make the sheet metal to contact these rolling operations. At the same time, the force also applied here. Not only contact, the force applied should not come back. Therefore, this sheet during rotation, a spinning action takes place here. This spinning action causes the material to slightly with the force, it is going to bend and form the specimen like this. So here also we are getting a small a tumbler. We are taking a tumbler here. This is somewhat a tumbler looks like. Okay? But the methodology of forming is different. Methodology of sheet metal forming is different here. We have bended in this some other route. We have bended, first we have kept and is keep on rotating. During rotation, I am keeping one more force and I am applying there in such a way like creating up a pot. You have seen in the olden days in the villages that they are creating a pot with the two hands. One is keep on rotating and another side we are keep on supporting to create the design. So such method is we have done as spinning methods. Very simply you can understand how these mud pots are created. Using mud pots. The red sand mud pots they are created. But with respect to this technologies, and we have inspired from there, and we are doing this in terms of spinning in the industries. So this is one of the other methods. So few more is there. Roll bending. We have seen the V bending operations where the die belongs to V. Here it is a simple change. Roll bending. Here the die belongs to roller. Here the die belongs to roller and we have the roll and we have kept this specimen here and it is going to bend. It is called as driven rollers. Freely it can be adjusted, adjustable rollers where I have to keep and stressing pressures has been done. So see, this is the original industrial image showing the machine setup, contains here the roller. This part is roller and we are going to press. So this is the die, you see, die contains the V shape, but the punching is a roller. So somehow we will not get a sharp product. We will get a slightly a ball shaped product we will get. So this here even though the die and with a combination of die and punch. So this is a terminology of bendability we should see. Here we are going to talk about the bendability. So bendability is nothing but while doing maybe the roll bending, maybe the V bending operations. So these operations when it is done, you can able to see in this image there is a crack at the stretched side. This side is the compressive side and this side is the stretching side. On the stretching side you can able to see the crack. Therefore, if let us assume we are doing the welding process and we want to check whether this welded component is having the capability of bending. Now we are doing the bending treatment through this V bending or roll bending operations. During those process, if the specimen does not having that strength mechanical properties, it is going to weld, the weld is going to break. And therefore, we can able to see some defects here. These defects are found through this bending treatments. So with respect to, we can tell a property as a bendability of welding is does not having this material not having the bendability property even after welding. So that are the things we should understand, that we should correlate those things with the welding and the defects. Factors affecting the bendability. Bending ability can be increased by increasing the tensile stresses. It can be increased by increasing the temperatures, increasing by the tensile stresses, increasing by the temperatures. It can be increased by increasing the pressures. It can be increased by the increasing the compressive stresses. So these are the various factors we should consider to get a proper bendability or bendability property. So it may affected by this tensile stresses. It may be affected by the temperature also. Welding, we are doing the operations in high temperature only. Then it's going to affect this bendability property. You should note this. And then it can be increased by the pressures and also by the compressive stresses. The remaining part will continue in the next session. Thank you.